know. The problem is everyone took tests last week and I got behind.
Hi, Joyce.
Maybe I'm just gonna make. Oh, hi, Joyce. Did you turn my speaker?
Hey, I didn't want to touch your phone. Do I put dismiss?
Oh no, it's fine. It's good.
Okay.
I think it's on.
No, it's not. You can just watch.
We should put subtitles. It's meeting.
So round number 42, Joyce. So far they've been pretty good on answering questions up till there. A was 2x, B was 2, C was 2, D was 2, E was 2. Everything around 1 was totally fine. At F, though, now we're coming in towards 0. From below 0 is 2. From above 0 is infinity. That's where people started getting confused. So I'm pulling it up here really quickly so that we can check it out, but it's taking a while. Was there another part to the question?
There was just.
Oh, H is D and E because they don't agree, right?
It was A through H. I almost cried when I said that.
Wait a minute.
And what page is homework on?
107.
It might be like 107, 108, 107.
Miss D,
107.
for G, was it limit as H approaches 0 from the right of 2?
Is it positive infinity? No, from the right of 0, isn't it?
The right of 1.
No, for G you're going to 0.
Yeah.
Sorry.
So it's 2 times H plus 1
Yeah.
minus 2 over H, right?
That's why I got the question wrong.
Oh, because you're approaching 1. Yeah, 1 was all 2.
That wasn't
No matter how you
it still
look at it.
exists if it's 1.
You
Wait,
guys
but
are
I thought-
approaching 0.
I thought you could do either formula.
You can.
No, you can. But George was going to 1 instead of to 0, so that's what messed him up.
But if you distribute
Got
the
it, but
2,
if you do as x approaches 1 and f of
Oh, I
x
see.
minus f of a over x minus
Let me
a.
get there.
Just like those numbers.
that's your just shake down. Joyce, leave a comment if you don't like those
See, it says that 1 on G.
Oh, wait, what?
Use the definition to find the right-hand derivative of f at x equals 1. If it exists. Why did it?
Huh?
They're poopers.
I did. Wait, what?
There's a typo, isn't there?
Somewhere.
Use the definition of left-hand derivative at x equals 1. Use the definition to find the right-hand derivative at x equals 1.
So it's it probably meant to, I mean, how can you.
Okay, it's a typo. Yeah. Hold on. You guys were right. It's wrong. Going to 0, it's right, but it wasn't going to 0 of this defined.
Maybe
Did they
meant to
plug
put
in
0 on
0?
the question. Did they mean to put 0 on the question?
Let's call it.
It's a different function too, though, isn't it? Or no?
Oh, it's 2.
Is it x squared?
It is x squared and then 2x.
Oh my god.
It's a piecewise, so coming from the left, it's x squared. Coming from the right, it's 2x.
Well, that's the problem.
Wait, no. At x equals 0, but you use the limit as h approaches 0. Right? So it's not a typo? So find it at x equals 1,
Yeah.
but h approaches 0, not x.
So the derivative of x equals
Yeah, you're
1.
right. They're using the alternative definition plugging in 1. So that clears up the 0 issue. I was thinking it was the alternative
No.
f of x minus f of a, but it wasn't.
My question is, I plugged it in, and it was 2 times h plus 1 minus 2 over h. So the 2's cancel, and the h cancels out on the top and bottom, so it should be 2.
Find the right-hand derivative to find the left-hand derivative. Does f prime of 1 exist? Explain.
You have 2h plus 2.
2h plus 2.
Because
Yeah,
that's
minus
plus-
2. 2h plus 2 minus
So
2.
you have 2h. Okay, I misunderstood the right.
Oh, duh. Okay. Sorry, it took me a second to orient myself. Yeah, no, the math totally works out in the sense of, as you come from below, everything is fine and dandy, and the limit, I should say the derivative at 1, and technically it'd be f prime of 1
Minus.
from below. Can I put that?
No, I mean,
From the left hand.
no, because it's, no, oh. the function is 2x, right?
From the left, it is x squared.
What about from the right?
It's 2x.
They did it wrong. If I may. May I go up there?
From the left is x squared, though, right? That is x squared.
But from the right, it's 2x. So
Which is
this should be 2.
They plugged in 1. So that is, yeah.
Oh, they plugged in 1 squared.
Well, yeah, that's,
Sorry, I just had flashback.
So it wouldn't be. Okay. Right?
it
Yeah.
should be 2 squared. No.
No,
No,
just be
times
2.
1. So
And then the 2's would cancel because it'd be
Because
2
it
minus 2 would be 0.
you'll take my
And then cross out the H.
And then the
Yeah,
h's
so
would
it's 2.
cancel and then it would equal 2.
Yeah, right.
There you go.
You see, these college graduates don't have faith in Gerardo.
Isn't it the professors that just like take the answers from the keyboard? They don't have
Right.
to work it out.
No, they give it to grad students probably.
Yeah, like they write the question and they have the grad students and they just
Yeah.
switch their answers.
So it does exist because the ones that limit degree.
Yeah.
Those
Although,
decaffeinated grants.
Not decaffeinated.
there is a slight dilemma though.
Yeah, lots of coffee.
Does anybody know what the slight dilemma is?
No.
Swag.
The derivative matches up,
But it's a sharp thing.
but the original is not continuous at 1.
Huh?
Because 1
And if the original is not continuous,
because coming from the left, it's 1 coming from the right.
the function is not differentiable.
So H is.
All
is-
right.
So technically, f prime of 1 does not exist because the derivative cannot exist at a non-existent, of a non-continuous function. Or of a continuous function at its discontinuity, I should say, properly from the definition that we talked about before. The
But yet the-
struggle is, I was thinking that the definition would actually work out to show that, because I think that's what they're trying to do, is to show that, hey, everything looks great with the derivative. But the derivative itself doesn't actually exist because of the discontinuity. I'm just trying to figure out why it didn't come up that way. Maybe they worded the question wrong.
Or maybe they're just expecting you to go. Because f prime of 1 explained. Oh, you're supposed to say no because it's discontinuous.
Because the limit does not exist. Or the limit to, yeah, the limit to
I wonder what would happen if, where were we? Over here? If they had done it generally and not specifically. Do you know what I mean? So if we had done, I'm trying to fit in so Joyce can see. If we had done the limit as h approaches 0 below of f of x plus h instead of f of 1, I think that's what they should have done is my,
It would still be like that.
Well, that would be kind of hard because f of x is piecewise. Oh, you never mind.
Yeah, come from the left. But can you come from the left to 0? Coming from the left to 0 would be coming.
From the negative.
no, you can. Because 0 squared, it exists below 0 and above 0, you know what I mean?
So 0 times 0 exists,
That's
yet
h
0
squared.
divided by 0 doesn't exist.
So that'd be 2xh plus h squared. That'd be 2x, right?
Yeah, if you pull out an H.
So then that'd be 2x, which would be 2x.
That's the derivative. That's what A was. Find a derivative for coming from the left. And then if you plug in 1, you're still going to get 2.
Yeah, it's not gonna make a difference, is it? I feel like they should have had you. I think the question was worded wrong. The way that I would have put it if I was writing it, which believe me, I do not want to write a textbook and it would be an awful textbook if I did. But if I was to write it, I would have said find something to do with discuss the continuity of f of x at 1. That's what I would have had you do. Something to do with discuss the continuity of f of x at 1. Because the point is you do want to come from the left hand and the right hand, but not of the derivative. That's not where the problem lies. The problem lies in the original, in that the limit as x approaches 1 from below of
the function is of x squared, which equals 1, and the limit as x approaches 1 from above
Is 2.
2x. Maybe they had their grad student actually writing this one, so they wrote it wrong. And then you can say it's discontinuous at 1, so therefore it doesn't matter whether or not the derivative matches up. Does f prime of 1 exist? That's an emphatic no. So I apologize for the question being worded wrong. It was a great idea, and I thought it was going to get you there, and it didn't.
What should be minus b?
So had you basically repeat the same process twice and not ever deal with the actual problem itself. Well, that's lame.
Can we legitimately sue?
For what?
No. Life is too short.
I mean,
Free speech.
Two more evens in
Symbolic
symbolic
speech.
There's nothing to sue for.
and yet people can sue someone for not giving you a tool bench.
Yeah.
44,
yeah.
that's the last one.
Yeah.
So that's false advertisement, first of all. Second of all, that's theft. I actually don't think it's theft. But it's
Final answer 3.
44.
However, before we go on trying to find the derivative from number 42, what it should have done, what's the very first thing you need to do?
Find K.
Find k to make it continuous, because the function has to be continuous first, and then you're allowed to go on and find the derivative.
Set it equal to each other?
Because remember, in order to make it continuous, you have to come from each direction.
And the slope
I
has to be
do
the
I
same.
think it only asked find K, didn't it?
No.
Yeah, it
Did
did.
I only write half?
I think it says something about differentiable, so it must have asked you to go on, but Amanda, check it out for me. Actually, I can check it
Because the slopes at 1 are equal, so if those points are touching at 1, you can derive there.
Well, if the function
What
is
is k
continuous.
equal? -2?
Oh, wait, was there anything on the upper side?
That's a good question.
It just says find the unique value of K that makes the function differentiable at x equals
So you would have to make it continuous and then find the derivative to make sure it's
Oh, okay, so I just didn't find to make sure.
right.
Oh,
I mean,
differentiable. You have to be continuous first and then differentiable second.
Got it, so I kind of just found that it was continuous.
Well, if it's continuous there, no, it may be differentiable.
It may be differentiable, but it's not. So that's why they're saying now we confirm. So they made it continuous and they were confirming it was differentiable. Otherwise, you have to say something to the extent of it's impossible to be differentiable.
Is a sharp point continuous?
Yes.
Okay.
It's like absolute value of.
Okay, in that case, would it be that it would be, it's continuous, but the sharp point is not at 1, it's at like some point after 1, because at 1 the slopes are equal.
For which function is it?
Yeah, 44. Because if you derive at 1, the slopes are equal.
Why is this a?
Well, this one, the function isn't a sharp.
It's not. It can't be a
Point.
sharp point. If
It's not a sharp
differentiable,
point.
It can't be a sharp point. Or a cusp, or a vertical tangent, or a.
If it was a sharp point, then we would be able to see either in the continuity or in the differentiability that something failed.
No, if you graph that, it's a sharp point. It's x cubed, and then it goes.
I think it does something like this, and then it just keeps on going in a line.
Yeah,
That's not a sharp point.
it's not a sharp point, even though that x cubed would kind of.
No, because the function a is continuous and b, the slope from one and the other agree. So it meets smoothly.
Yeah.
Instead of
Oh.
continuing a curve.
Oh,
Your
it meets
sharp point is where the slope from one direction and the others don't agree.
Oh, but this one meets smoothly.
Does that make sense?
Yeah.
I would have to draw it better to be able to show that, but basically the slope of this line is exactly the slope of the tangent
Right.
line, so therefore it meets smoothly. Does that make sense?
Mm-hmm.
I have a lot of
A
questions.
good question. Questions on odds on this section.
Oh, odds, I think
Okay, any questions on 3.1? Any further questions on 3.1? Going once, going twice?
so.
Alright, let's go ahead and move on to 3.2, so 3.16. Let's check the evens first. I'll probably get you guys to the boards for any questions that you have beyond that.
Solid.
8, 4.
So, hold on, quick review. Where are we going? Number 8 first?
Mm-hmm.
A, all points except -1, 0, and 2.
I should have just done that. That would have been more sense.
0,
We're
negative
trying to
1.
do intervals like
Yeah.
-2,
Yeah, that's what I
-1.
did.
Yeah, I
You
did
can
it.
do that.
I did intervals.
You can do that's fine.
I know, but it would have been simpler to just do that.
They're saying all except, so x not equal to in that.
Because B and C
Wait.
Are the places where.
Yeah.
Because I got it can't equal -2 or 1 or
No, it can't
3,
equal
-3 or 3.
Nope, you're thinking the endpoints again, Gerard. Remember, you only have to come from one direction at the endpoints.
It tells you the domain.
Some of the go.
Goat? That's a new one.
Yeah, it is a
Son of a
movement.
goat.
Son of the greatest of all time.
Joyce, I hope you're enjoying this.
She probably like mutes
Where are we on
us.
number
No, I know. She told me, she
Number
was
eight.
like, you guys ask a lot of questions.
I bet we do.
You guys
We
are
do.
some of us.
Yeah.
Because we're trying to find differentiable.
Wait,
So Gerardo, you were thinking this is a sharp point, the endpoints, but they're not because we only have to come from one direction, and the point, the slope. Well, first the point is there; it's continuous, and second of all, the slope agrees. So then we're fine.
So not at -1. and
Not -1, not 0, and not 2.
Not -1.
Sharp
Not
point.
0.
Not 0, discontinuous, and not 2, discontinuous.
It's not differentiable at 2.
Remember, if it's not continuous, it can't be differentiable.
Really?
You can't have a rate at a point that doesn't exist. Or I should say, of a function at a discontinuity.
But -2 is good. 3 is good.
Because the slope is fine, the point is fine. It's continuous, and you only have to worry about the slope from one direction.
And 0 is not. Okay.
Moving back, what's pass number 8?
Wait, did you go over B and C too?
Oh, it was just which one was which. So at -1, you have, it's continuous but not differentiable because the one-sided limits don't agree. So the derivative does not exist. And then at C, you have discontinuities at 0 and 2.
I did not do that.
It's 0 and 2.
Yeah.
Well,
0, the limits do not agree. So
Oh,
the
I thought-
function is discontinuous. And at 2, the limit does exist, the point does exist, but they don't agree.
No, I thought we were looking at 9. GJK.
Close the end. What's our next even?
14.
14.
Number 14, here he is. Vertical tangent. 4K, it's an infinite slope.
Oh, are you just finding the derivative?
I derived and I mean,
Ultimately.
It tells you that it's
I
discontinuous
mean, you
at
could look at
0.
the graph, but that'd be more complicated, I would believe.
It tells you it's discontinuous at 0, so then you're supposed to find what kind of discontinuity it is.
Can we talk about what
oh,
the difference is
oh,
between a
yeah.
corner and a cusp?
Oh, ooh,
Because I don't know what either of those even are.
Yeah,
I
let
know
me
what a
open up
cusp
our
is.
notes though, because I would prefer to write that down.
Okay.
Just for visual understanding of that.
Because I don't know.
George.
Do we have to make notes like mandatory?
My
Yeah.
question is, are we going to do endeavors today? Or do we do that on our own time?
No, we're gonna do them eventually, but today is not the day.
We're gonna do them tomorrow because we don't have very many homework questions because it's literally section 3.3, which is go find derivatives the fun way.
Yes.
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 Everything
Funny
except for
story.
trig.
I did.
Wait,
Oh,
so no
no,
trig? Is that what-
trig.
Except for trig.
Oh, the trig's not in it?
Trig's the next
But I, have
Yes.
trig, but I wrote down trig derivatives, and that was
Whoa,
it took like a
me
whole
too.
day to me to figure this out.
Gerardo, it's coming. Don't worry. It's
Don't
coming.
even
Why
worry,
you
it's gonna
want
be
trig
there.
derivatives?
I hate
I'm
you.
pretty sure hell consists of 2 things: working out all day or taking trigonometric derivatives.
All right, hold on. What are the other ones that we have to face? We have vertical tangents, sharp points, which would
Not
be
16.
I just said
cannot figure it out.
quarter, cusp, or vertical
Quarter. I
tangent
took
line.
quarters to be as sharp points. 'cause
Yeah.
They make a corner.
Is that
either
what
the
the
corner and the
cusp is
cusp are
like-
basically both sharp points.
both
But-
sharp points?
Aren't cusps like the like what you get in like polar things or parametric thingies?
Does that make sense?
No.
Okay.
But it's okay. She's gonna write
No,
it
they
down.
are with limicons, but they come to a point. They come to a sharp point.
Spanish.
So this is what we didn't get to finish on Friday.
No, I just like.
Vertical tangents. Question. Is this function continuous?
Yes.
Yes. If it wasn't continuous, could we have a derivative exist? That's the part that we didn't get to write down on Friday.
Wait, we can't have a derivative exist at that point, at a certain point, right?
Interesting.
Huh?
Yet that point.
You can't have the derivative exist at the point where it's not continuous, but you can have it everywhere else, right?
Right.
But what if you made it piecewise and fixed that? Then you
So if I was to do, well, that's you making it though. That's not what's inherent to the function itself. Oh man. Real quick, since we're practicing derivatives, since that's basically what all next section is, what's the
One
derivative
over
of square root of x?
1/2 square root.
Because you bring down the 1/2, subtract 1, negative 1/2 power. There we go. So what's going on at f prime of 0?
This is 1/0 infinity.
1/0, which leads us to, and technically 0 of square root of x in its domain will only come from the positive side, so hence positive infinity. But long story short, what's going on with the slope of the tangent? What kind of slope is it?
Infinite.
Infinite, which means we have a vertical tangent, right? with sharp points, and this, I think, technically, this example would be a corner, I do believe. I know the difference. A corner isn't just literally 90 degrees or even some sort of two lines coming together. Cusp, just hang in there. Corner, okay? A corner at x equals 0. Corner is our sharp point. I'm actually just going to put corner. I'm going to leave it. What goes on when I take the derivative? I have to come in from two different sides, right? Because it's technically a piecewise. So then I have for x less than or equal to, well, less than 0. Let's just do that. And then x greater than or equal to 0. Uh-oh. I'm not going to put or equal to because as I come from the left, I have a negative 1, right? As I come from the right, I have a positive 1. So what's going on at f prime of 0?
It's a point. It's a sharp.
F prime of 0 does not exist. Why? Because the one-sided, we could say something like the one-sided derivatives. Is that okay? So as you come from one side or the other, bless you.
Thank you.
The one-sided derivatives, because derivatives at their core are limits, do not agree.
Steve, can we, sometime, whenever, can we go over how to split up absolute values again?
Can I just show it right here?
Yeah.
If that's like not wasting time.
It's not wasting time because it's applicable, I would say. Absolute value of x is equal to, remember, x, if x is a positive number, it stays the same. So if x is 5, the answer is 5 coming out of an absolute value. But if x is any negative number, so if I had negative 5, what would I need to multiply a negative 5 to get a positive 5? Does that make sense? And hence derivative, negative 1 and 1.
Wait. You put it in negative x, but wouldn't that just make it positive?
That's the point.
Yeah, that's what absolute value does.
Never mind. I figured it out.
Yeah. What if we were to do sharp point with a cusp? I have to think of a function. I have a picture.
Oh, I got one.
It's the one
1
that goes
over
like this.
3 cube root of x squared. Negative.
1 over 3 cubed root of x squared.
Negative 1 over 3 cube root of x squared.
Oh, we could do positive, I think, either.
Because if it's cube root of an x, it's the symbol s.
Oh, that would work. Fine, we'll take the derivative of that. You can
Josh.
try.
Because if it's the cube root of x, it's this thing, and if it's cube root of x squared, that's kind of like the cube root of absolute value of x. So it would make the.
It'd be this one in like number 9.
Yeah.
Absolute value of sine.
Sam.
I could do
George
that.
said no.
No.
We could do sine. It's easier than tangent inverse.
Definitely easier than 10.
Oh
It's
yeah.
like
That was just
root
that
x
was just
over
the first thing that
left side.
came into my mind.
Cusp.
Looks like a mustache.
Now, is it a sharp point? Yes. But it's also a cusp. Two different concavities coming in towards, there we go, the same point. If we were to find the derivative, we could, right, George? We could go ahead and split this up into a piecewise. And how can we define it?
Sam's too smart.
From the right, it would have to be.
Can we zoom in just right here? Is that okay?
Yeah.
So we have negative pi to pi, yeah?
Yeah.
So we'll do x between negative pi to 0. And then we'll do x within 0 to pi.
Is it supposed to be open on the 0?
Yeah.
Oh, because one of them's equal to.
Yeah, I just did one. So then if we're over here, it's being flipped, so it'll be negative sine of x, right? And then if it's over here, it's going to be positive sine of x.
Wait, why is it negative sign?
Because you have to.
Because sine normally goes down, and I need it to flip up. It's like a vertical flip.
No, forget it.
So if I go to find my derivative, f prime of x,
It would be cosine and then.
I would have, yeah, cosine of x and then negative cosine of x, which would be fine in the sense of I can plug in any values between 0 to pi, no big deal, and negative pi to 0, no big deal. But why did I leave 0 open?
Because it's not defined there?
Because the derivative is technically a limit, and as I come in from the right, what would be f prime of x
Negative
as x approaches 0 from
1. The right would be 1.
the right? I would plug in cosine of 0, and cosine of 0 is 1. And then as x approaches 0 from the left, f prime of x would equal negative 1, because negative cosine of 0. So once again, the one-sided limits, or I'll put in idea the one-sided derivatives, which are defined by limits, do not agree.
So to show the difference between a sharp point and a cusp, you need to know the graph. Pretty much.
I'd say, I mean, it's still basically the same idea in the sense of the one-sided limits not agreeing. I think the distinction, I had a different picture in my head when I wrote that one. Let me check that out, between the corner and the cusp. What was the other one? Discontinuity? Oh, guys, we don't need to write down discontinuity because, once again, if it's discontinuous, that was the fourth category, I believe.
No,
If it's discontinuous, there is no derivative, right?
It was just vertical tangent, sharp points, and corners, or cusps. I mean.
We can just, I guess, add.
It says or discount.
It says or discount. Okay.
It does.
There you go.
Oh, or you just- my bad.
All right, let's go back. Where are we at now?
16. I need help with that.
Yeah, me too.
Okay, we give you a second.
I mean,
That's what I think it was an infinite, and sine isn't infinite.
say that again? Misty, for that, for 14, I just did power rule. Do I have to do this?
I know, it's a chapel day.
Stink.
But the nice thing is, you guys don't need to take any notes on section 3.3, because what are we doing?
Power rule.
Power rule, constant
Quotient
multiple rule,
Constant multiple product.
quotient product. Go play with derivatives tonight, everything basically except for trig, sound good?
Yeah.
And probably no chain rule. Don't make any mistakes.
Hey.
And I give you guys all evens, and then we'll grade it. Virginia needs a quiz too. That'll be fun.
All even.
Misty, I'm gonna have someone come in and get the donuts in the car.
Okay, is that cool?
Misty, don't you remember all my answers?
We didn't get to finish our evens either.
I didn't get to finish the last 4 questions of this section.
Yeah,
Same.
we need to, this was hard. It's hard.
Alright, so tomorrow we'll go over the end of this and we'll grade. Sound good?
Awesome.